We are so close to a revolution in medicine. But what if I told you a single tiny flaw could make the whole thing incredibly dangerous? Well, today, that's what we're digging into, the big problem with small medical AI.
Okay, just think about this for a second. What if you could have the expertise of a top doctor right in your pocket? I mean, literally on your phone. Or maybe it's built into a handheld scanner that a paramedic can use right at an accident scene. That's the dream, right? Powerful, life-saving AI, ready to go anywhere, anytime.
But, of course, there's always a catch. See, shrinking down a brilliant, super complex AI so it fits on a tiny chip, it's not like just zipping a file to save space. When you do that, you can accidentally create these subtle, really dangerous flaws. And we're not talking about a bad song recommendation here. We're talking about life and death. And that brings us right to the heart of the issue, what you could call the AI doctor's dilemma. Trying to make these AI models smaller and more efficient, it's like performing delicate surgery. You have to be so careful about what you cut out, because one tiny wrong move can have, well, catastrophic results. In fact, it's not just a theory. A recent massive analysis looked at over 600 research papers on this exact topic, and what they found was pretty alarming. They identified 7, that's right, 7 critical gaps. These are specific areas where these small, lightweight AIs are just plain failing the safety tests for real-world healthcare. So today, we're going to walk through the 3 biggest hurdles that this creates.
All right, so hurdle number 1. This is the big one, the most fundamental question of all: accuracy. Can a shrunken down AI still make the right call when a life is literally on the line?
So one of the main ways engineers shrink an AI is with a process called quantization. The easiest way to think about it is like this. You've got this beautiful, super detailed, high-resolution medical scan, right? Quantization is kind of like squashing that file down into a smaller, lower-quality JPEG. Sure, you save a ton of space, but you're also losing some of that fine detail. And in medicine, the question is, how much detail can you really afford to lose? And this is where you really see what's at stake. Look, for a general AI, like the one that recommends movies on Netflix, a 5 or 10% error rate is whatever. It's annoying, but it's harmless. But in medicine, no way. The acceptable error rate has to be less than 1%. Why? Because a single misdiagnosis, just one, can be absolutely catastrophic. Okay, and here's the truly terrifying part. When you compress a medical AI, it doesn't just get a little bit worse at everything across the board. No. It might stay pretty good at spotting common stuff, like the flu, but it gets disproportionately bad at spotting those rare but critical diseases. We're talking about things like an early-stage cancer. It completely loses its ability to find the needle in the haystack. And this problem goes way beyond just images. See, a modern medical AI has to juggle all sorts of information at once, what's called being multimodal. It has to look at a patient's X-ray, read their lab report, and monitor their live heart rate, all at the same time. The danger is that compression can snap the links between these different types of data. Suddenly, the AI is blind to a critical pattern in an ECG, and it might completely miss the warning signs of a heart attack. Okay, so accuracy is a huge deal. But let's say you solve that. Even a perfectly accurate AI is totally useless if doctors and patients can't trust it. And that brings us to the second great hurdle: trust. And trust really boils down to 2 things: privacy and transparency. So a really common technique is to use a big, powerful teacher AI to train a smaller student model. But it turns out this whole process can be leaky. Researchers have found it can accidentally spill private patient data in 3 different ways. It can be used to figure out if you were part of the training data, it can reveal sensitive details about you, or, and this is a scary one, it can actually memorize and reconstruct the entire case of a rare patient. We're talking about a massive privacy violation here, and something that could get you in huge trouble with laws like HIPAA. Now, the other side of that trust coin is something called explainability. With a full-size AI, if it makes a diagnosis, we have ways of asking it, hey, why did you think that? And it can show us what it was looking at in a scan. But when you compress that model, it can turn into a total black box. If it makes a mistake, we might have absolutely no idea why. And you can bet that for regulators like the FDA, an unexplainable medical device is a complete non-starter. All right, so we've covered accuracy and trust. Now for the third and final hurdle: the real world. It's one thing for an AI to work in a perfect, clean lab, but how does it handle the messy, unpredictable, chaotic reality of an actual hospital?
Think about it.
In the lab, the AI gets to train on this perfectly clean, uniform data, all from one hospital system. But the real world, it's messy. Every hospital uses slightly different equipment, the patients are more diverse. This gap between the clean lab data and the messy real-world data, there's a term for it. It's called domain shift. And what it means is that an AI that's an absolute genius in one hospital might completely fall on its face in another. And this right here is where it can all just fall apart. You see a full-size model, and its accuracy is great. Then you look at the compressed model in a lab test, and you think, hey, that's still pretty good. But then you take that exact same model and deploy it in the real world, running on a low-power device, and its performance can absolutely plummet. That combination of being compressed and facing real-world chaos, it's just a recipe for disaster.
Okay, so the challenges are obviously immense. But, identifying the problems is always the first step to actually solving them. And the good news is the research doesn't just point out what's wrong, it also helps chart a clear path forward. So the big question is, how do we fix this? The core message is really clear. We need a fundamental shift in how we're doing things. First up, researchers have to stop caring so much about average performance and start obsessing over those rare life-or-death cases. Second, privacy and transparency can't be an afterthought. They have to be built in from the very beginning. Third, you've got to test these things in multiple, diverse, real-world hospitals, not just a clean lab. And finally, and this might be the most important one, AI experts have to get out of their labs and work side by side with the doctors and nurses who are actually on the front lines.
Look, the dream of a powerful, pocket-sized AI doctor, it's amazing. It's so compelling. It could literally democratize healthcare and save millions of lives. But as we race to make these tools smaller, faster, and more efficient, we just have to hit pause for a second and ask ourselves a really important question. Are we building this future safely, or are we accidentally creating a brand new kind of risk? How we answer that is going to define the next generation of medicine.